let's go to LeetCode number 71, simplify paths. So the question given a string path, which is an absolute path. You start with a slash to a file or directory. And after slash, then we can have the folder name or some other passes after that. And it let us to convert this kind of path to be canonical path. So the canonical path has the following conditions, and for the absolute path, it also have this kind of it is like a unique system, which has a dot refers to the current directory, and the two dot refers to directly up label. And double slash treated as a single slash. Any other formatted pairs such as dot are treated as file directory names. And then it lets us to convert the string, the path to canonical path. Canonical path is the path that with slash. Any two directories separated by a single slash. The path does not end with a trailing slash. So we'll see there is no trailing slash after home. And the path only contains the directory on the path from the root directory to the target file or directory. So for this question, the things that our thinking is that we read the original path. We separate the original path by the slash sign. And let's take this example. After we separate, then we'll have home, we'll get a string array home. And the second one will be empty and full. And after that, there is an empty string. So if we made something like two dots, the thing is that if we get for the every string of the string array, if it is just a normal characters string, we can use something like stack and push this kind of string to a stack. And if we made it two dot, we just pop the previous one. And in the end, for example, let's if this is for example this dot, we push this home, and when we made two dots, we just push home out. So this kind of directory is we go to the up. Then in the end, there is something left on the stack. We just compose it to the canonical path. So let's write code. We use the stack. Here, I write stack instead of stack because the stack in Java is kind of out of date. So we use the stack here. Then for string path split. So we need to consider this kind of string for many scenarios. So if equals This means if the stack is not empty, we are going to pop it. And if str let's put a if else if this one equals if it is one dot or it is empty string. We just do nothing. Let's continue. Otherwise, we just have the stack push this string. In the end, what we need is that we need to compose the compose the stack, the strings in the stack to the result. We are going to use a string builder. So in let's try to see as we already use the deck here, we can use instead of, because we need to reversely convert those kind of string builder. So as we already use deck here, we can use deck's pop last method. So actually, why is anything? This is a method belong to pull last belong to deck queue. Deck, DEQE deck, not a method of stack, but we already use the deck here. For last, and we return the string. So we'll take a basic example. And let's take an empty string, trying to see what it looks like. Had to be size at least one. So if we put like this, so yeah, this so in this case, that means because it is empty, right? So there are always empty string. That means that if this stack we get nothing, we should append if stack is empty. Just have the string and this. Comment. There's some issues if this is dot stack isn't empty, then it should be else, because we also push the dot inside this. Let's test this kind of case again. Let's talk about the time complexity and space complexity as we iterate the path and assume the length is n. The time complexity will be O(n). And also we use the stack. It's a linear data structure. So the space complexity is also O(n).